The ancient peoples called it the morning star or the evening star because it is the brightest object in the night sky after the moon. But in reality, it is a planet, Venus. It is the closest planet to Earth and has many characteristics similar to our own planet. Due to its beauty and outstanding brightness, the Romans named it Venus, after the goddess of beauty and love, equivalent to Aphrodite in Greek mythology. It is the only planet in the solar system with a female name. When it is at the point in its orbit closest to Earth, Venus is 41 million kilometers away from us. So close that with our current spacecraft, it would take about a month to cover this distance. At the moment, Venus is 45 million kilometers from us, or 2.5 light minutes away. Traveling at the speed of light, considering only the velocity, we would reach Venus in just 2.5 minutes. Let's head to Venus. Venus is one of the most fascinating planets in the solar system, so physically similar to Earth, yet so drastically different. The planet Venus was formed from the same clouds of rock debris, dust, and gas as Earth, around 4.5 billion years ago. This is one of the reasons why Venus is often referred to as Earth's sister planet. Gravity stabilized the planets, and Venus settled into the second position from the Sun. Venus is the second closest planet to the Sun. Its average orbital radius is 0.7 astronomical units, or approximately 108 million kilometers. It does not vary much from this average orbital radius, as it has the least eccentric orbit of any planet, moving in an almost perfect circle. At its closest approach to Earth, Venus is only 41 million kilometers away. Curiously, this is not when it appears brightest in the sky. At its closest approach, we see only its dark side, since it is positioned between the Sun and Earth. However, it is still visible because sunlight refracts through its atmosphere. In fact, Venus is brightest when it appears as a thin crescent in the sky, and when this happens, it becomes the brightest object in the night sky after the moon. All planets orbit the Sun in a counterclockwise direction, and in this regard, Venus is no different. However, unlike the other planets, its rotation is in the opposite direction, a phenomenon known as retrograde rotation. The origin of this peculiar motion is still debated. For a long time, scientists believed that a catastrophic impact with a massive celestial body could have reversed its rotation. However, more recent research suggests that gravitational forces and atmospheric interactions over billions of years may have gradually slowed and eventually reversed its movement. This means that Venus is the only planet where the Sun would set in the east. Due to this unusual and extremely slow rotation, a day on Venus lasts 243 Earth days, the longest of any planet in the solar system, even longer than its own year, which lasts 225 Earth days. To put this in perspective, Earth rotates at a speed of 1,670 kilometers per hour at the equator, while Venus spins at only 6.5 kilometers per hour. If we could walk on its surface, we could keep up with the Sun's motion and never see it set. This slow rotation makes Venus the second most spherical object in the solar system after the Sun. Venus shares many characteristics with Earth. Its mass, size, distance from the Sun, age, and composition are very similar to our planet. Because of this, it is often called Earth's sister planet or twin planet. Venus has a diameter only 600 kilometers smaller than Earth's and possesses 81% of Earth's mass. Its density is 5.2 grams per cubic centimeter, compared to Earth's 5.5 grams per cubic centimeter. This means that gravity on Venus is only 10% weaker than on Earth, with a surface gravity of 8.8 meters per second squared, or 0.9 Gs. Venus also has an internal structure similar to Earth's. The planet has a large iron core, about 6,400 kilometers in diameter, surrounded by a slowly moving mantle of hot rock, driven by internal heat. Venus was the first planet successfully explored by a spacecraft. The Mariner 2 probe, the same mission that visited Mercury, scanned Venus in 1962 from 34,000 kilometers above its clouds. Since then, the planet has been studied by several other probes and has even been mapped by radar, revealing many details of its surface and topography, since its highly reflective clouds block any direct view of the ground. The map was color-coded to indicate altitude. Cooler colors like blue and purple represent lower regions, while warmer colors like orange and red show higher elevations. At first glance, Venus looks very similar to Earth. But this is where the similarities end. Most of Venus's surface is covered in vast volcanic plains. While Earth has about 1,500 active volcanoes, Venus may have once had hundreds of thousands or even over 1 million. Research suggests that around 500 million years ago, Venus went through a catastrophic global volcanic event, covering nearly its entire surface in lava. This event completely resurfaced the planet, erasing almost all geological history before that time. NASA's Magellan mission revealed that Venus is home to an incredible variety of volcanic formations, including giant lava channels, volcanic domes, and strange circular structures called coronae, which may suggest that volcanic activity is still happening today. The conditions on Venus's surface are brutally hostile, primarily due to its extremely dense and toxic atmosphere, which makes the planet one of the hottest places in the solar system. Let's take a closer look at Venus. Venus has the densest atmosphere of any rocky planet in the solar system. It is composed primarily of carbon dioxide, with a thick layer of sulfuric acid clouds and a small amount of nitrogen. The cloud layer sits above the thick CO2 atmosphere and is made mostly of sulfur dioxide and sulfuric acid droplets. Sulfuric acid is highly corrosive and falls as acid rain, adding to Venus's hellish nature. However, these raindrops never reach the surface. They evaporate at around 25 kilometers above the ground. These clouds are also capable of producing lightning. Much like on Earth, though they are less frequent. The wind speeds in the upper cloud layers are significantly faster, reaching up to 300 kilometers per hour. These high-altitude winds circle the planet every 4 to 5 Earth days, making it appear as though Venus is spinning much faster than it actually is. The atmosphere creates the strongest greenhouse effect in the solar system, with temperatures reaching 475 degrees Celsius, and in some regions exceeding 500 degrees Celsius on the surface, hot enough to melt lead. To put this into perspective, that is almost 10 times the highest air temperature ever recorded on Earth. This makes the surface temperature of Venus even higher than that of Mercury, even though Mercury is the closest planet to the Sun. And Venus receives only 25% of the solar radiation that Mercury does. The continuous greenhouse effect makes Venus the hottest planet in the entire solar system. But temperature is only part of the extreme conditions on Venus. At the surface, the atmospheric pressure is 92 times greater than on Earth. This is equivalent to the pressure found 900 meters below the ocean on Earth. On Earth, we have about 100 kilometers of air above our heads. On Venus, the atmosphere extends 250 kilometers up. If someone could somehow survive the extreme heat and toxic gases, simply moving around would be incredibly difficult due to the immense air density. You may have heard that on Titan, Saturn's largest moon, a human could fly using wings strapped to their arms due to the thick atmosphere and low gravity. On Venus, however, this would be impossible. No matter how strong you were, the air resistance would be too great to flap the wings. And yes, a human could fly on Titan using only their arms, provided they had a set of wings, an oxygen supply, and a heat suit. To understand just how intense Venus' atmospheric pressure is, let's compare it to deep-sea diving on Earth. Professional saturation divers who work on deep-sea oil rigs descend to depths of around 300 meters to operate valves or repair equipment. To perform this job, they must spend about 10 days inside a hyperbaric chamber to adapt to the pressure. At 300 meters deep, the pressure is about 30 atmospheres, which is roughly 45 tons, or the weight of 56 cars pressing down on their bodies. Without proper adaptation, the mechanical pressure would crush the lungs, rupture the eardrums, and cause severe internal bleeding due to the compression of air-filled cavities in the body. On Venus, the pressure is so overwhelming that it would feel like being 900 meters deep in Earth's oceans. The air is so dense that it could crush a car with ease. During the space race, the Soviet Union launched a series of missions to study Venus in the 1960s, 70s, and 80s. This program was called the Venera Project, which means Venus in Russian. The goal was ambitious: land probes on Venus and study its surface. Naturally, this was an incredibly difficult challenge. Venus is one of the most hostile planets in the solar system, and most of the probes didn't even survive long enough to reach the ground. They were destroyed by the atmosphere shortly after entry. A total of 16 Venera missions were launched, but only 5 successfully landed on Venus. Even these landers survived for only about 50 minutes before being crushed and melted by the extreme conditions. The Venera 4 probe, launched in October 1967, barely made it into Venus's atmosphere. Before its sensors began recording extreme temperature rises, it detected 11,000 degrees Celsius, twice the surface temperature of the Sun due to the immense friction and heat from atmospheric entry. Even more astonishingly, as it descended, the probe experienced 450 Gs of force, the equivalent of an impact, 450 times Earth's gravity. As time passed, the temperature readings continued to rise. After about 93 minutes of descent, at an altitude of 27 kilometers, Venera 4 was completely crushed by Venus's atmosphere. Until that moment, scientists had no idea how incredibly dense Venus's atmosphere really was. Through trial and error, and after many failed attempts, the Soviet Union gathered valuable data about Venus. Then came Venera 13 and 14, which finally succeeded in capturing the first ever color photographs of Venus's surface. The images revealed an orange-tinted sky. Venus' thick atmosphere absorbs blue light, meaning everything appears in shades of yellow and orange. The landscape is dominated by dark, layered rocks and fine-grained soil filling the gaps between them. These images exist only thanks to the incredible efforts of Soviet engineers, who insisted on landing probes on Venus, one of the most difficult planets to visit due to its hellish atmosphere and its ability to crush anything that enters it. They confirmed that Venus is so hostile that no earthly life could possibly survive there. But that wasn't all. One of the Venera probes also recorded the sounds of Venus. Turn up the volume and listen. You are about to hear the real sound of another planet. At first, it may just sound like wind and mechanical noise, not much different from what we hear on Earth. But this is the actual sound recorded on Venus. It has been decades since we last got a glimpse of what lies beneath the thick clouds of our scorched neighbor. But that is about to change. Venus is about to receive new visitors. One of the most exciting upcoming missions is NASA's Da Vinci. This mission will study the origin, evolution, and current state of Venus, from the top of its clouds all the way to the surface. Its launch is planned for 2029, so we still have a few years to wait. But during a flyby, the Da Vinci spacecraft will release a descent probe equipped with a camera, allowing us to see Venus like never before. During its 1-hour descent, the probe will take thousands of measurements and capture close-up images of the surface as it emerges from beneath the thick clouds. The probe is not expected to survive the landing, but if it does, it could provide up to 17 additional minutes of priceless data. Unfortunately, the Da Vinci descent probe does not include a panoramic camera, meaning that the old Venera probe photos may remain the best images we have of Venus' surface for many years to come. If the Romans had known what conditions were like beneath Venus's clouds, they might have thought twice before naming it after the goddess of love and beauty. Or maybe, deep down, they sensed Venus once had a paradise-like past. Studies suggest that billions of years ago, Venus's atmosphere was far more Earth-like than it is today, with large amounts of liquid water on its surface. Evidence indicates that Venus may have had oceans for up to 3 billion years before succumbing to a runaway greenhouse effect. Recent climate models suggest that for most of its history, Venus' atmosphere could have been much more similar to Earth's than it is now. However, as the sun grew hotter and brighter over billions of years, Venus's oceans began to evaporate. Water vapor, a powerful greenhouse gas, intensified the planet's warming, leading to the complete loss of its water and the creation of its hellish atmosphere. Venus may once have been a promising world for life. Today, it stands as a warning, a stark example of what can happen when a planet's climate spirals out of control. After visiting Venus, we return to Earth, our incredible home, a reminder of just how valuable and fragile our world truly is. Thanks for watching. This was another journey in our solar system exploration series, where we visit the major planets, dwarf planets, planetoids, their moons, and key asteroids. Next, we'll take a closer look at our own planet. See you on the next flight.